Ooh, why is it on this page? That's weird. All right, everyone have a chance to do the bell work? Well, that's super weird. Huh. Okay, well that's strange. It was on this. All right. Everyone quickly do this problem. And give me a green check when you are finished. Yeah, sorry about that. Volunteer that'd like to do this for us. Go for it, Enzo. Or Brady. Or do it together. Enzo can do it? Okay. Enzo, go for it. All right, so he wrote down the 2 points that would be found on the parent function. And 1 comma 0 because all log functions cross at 1 comma 0 that don't have shifting. And then 4 comma 1 because of the base being a 4, so it crosses at 4 comma 1. We learned that yesterday. And he says that it has a vertical shift of up 2, so that's why he is only adding 2 to the y value to get these 2 points. So there's 1 comma 2, and then there's 4 comma 3. Good enough, right? Good enough. Good enough for being on the computer. All right, did everyone get this one correct? Did everyone see that +2 as a vertical shift, or did you see it as a horizontal shift? And you shifted left 2. Anybody make that mistake? Vertical, because no parentheses. Perfect. Yeah, that's exactly why. Right. Yeah, because there's no parentheses around the x plus 2, we are only logging the x, and we're not logging x plus 2. Now, if there's parentheses around it, then yes, it would be a horizontal shift to the left 2 units. But yeah, this is our vertical shift. We are only logging this x. Very good, everyone. Okay, converting between forms. This is kind of gonna feel like yesterday because the way that I taught yesterday's lesson, which is good. This is gonna feel like review and maybe a little easy. So this is from yesterday. This just shows going from log form to exponential form in the math that we did. So for this one, we base b both sides. This cancels out, x carries down, and then we have our answer. Over here, we had to log base b both sides to make this exponents come down in front. It's one of the log properties, and then log base b of b. This becomes 1, and 1 times anything is itself, and that's how we get the answer. This just carries down. But yeah, here's the little graphical conversion of this, just to show this. And we'll do one like that just to show how it works. So we got these 4 examples. We'll probably only do like 2 of them. But let's start with this. So everyone try to use this change formula to go from exponential form to log form. So try to use this, and then once you finish that, try to do it the mathematical way we learned yesterday. Give me a green check when you do that. What did everyone get for their answer in log form? So y equals log base 3 of x. Anybody else? So same thing, x equals log base 3 of y. Oh, different answer, sorry. Different than Brady's. I inverted, and I don't think I was supposed to. Right, yeah, so we're just converting. We're not finding the inverse. This is similar to yesterday, but instead of finding the inverse, we're just rewriting the equation from log form to exponential form and vice versa. It's basically the same thing without actually, well, switching x and y. Yeah, so they're right. So to use this little conversion thing from yesterday, same thing for today. We can take this form here and we just make it fit over here. So we're going to have y equals, and that y value was the exponent. So the exponent is x in this case. So we're going to write in x. Oops. And then, so we got that exponent, the x equals, and then we're going to have log base. Now the base is going to be the base of the original exponent form, so 3. So log base 3. And then lastly, we are doing the log of the number is going to be, well, the original, what it equaled, which is y. So not difficult. It just feels kind of clunky. If you like doing it that way, knock yourself out. That's how the module does it. It's my least favorite way. And then everyone should have done the way we learned yesterday. So given this problem, 3 to the x power, to convert it into log form, what do? Log base 3 both sides, yep. And we're gonna log base 3 and log base 3. So what happens to the x? It drops down in front, but the property says we do what to it first? Yeah, we bring it in front. It's a property. It's same idea. We should get in the habit of doing this to show this property in action versus just dropping it down. And then what does log base 3 of 3 equal? Yeah, equals 1. So that equals 1. And 1 times anything is itself. So we get down to the final answer. X equals log base 3 of y, which is the same answer by using that little change formula. Fun stuff. So for these, we don't flip the x and y, right? Correct. Yeah, we don't flip the x and y. So we only flip x and y when we have to find the inverse. So if the directions say, find the inverse of this equation, then yes, we would flip x and y, then solve for y. Now, if the problem says, write the equation in log form, like it does, or write the equation in exponential form, then you wouldn't do any switching. Good question. Nobody asked that in 830 class. Huh. Well then, hopefully they know. Okay, everyone, do this one. You can either use this little change formula deal or do the math we learned yesterday. And give me a green check when you finish. All right, everyone is done. That is here. All right, what did all of you get in log form? A equals log base b of 89. Same thing. Yeah, that sounds right. That sounds right. So what did all of you do for your first step on this problem? Log base b both sides, yep. What happens to that a? Yeah, it goes in front. So this a goes in front. It's one of our properties. And then this cancels out and becomes a 1. I'm just going to show that work in one step. It kind of looks like there's a lot going on, but not really. So we have a times 1 is just a, and then the answer, like all of you said, log base b of 89. All right. I think we got this down pretty good. All right, let's skip these. Let's go to this one. Now, feel free to use this little change formula to go from log form into exponential form. or do the math we learned yesterday. Give me a green check when you finish that. All right, what did everyone get? X to the y power equals 71. That sounds right. And we could use this, or we can just do the math. I'm going to just show the math here. So what did all of you do for your first step on this problem? So you base x both sides, base 71 both sides, base x. Okay, Enzo says just kidding. Base x both sides. All right, and that's because we have log base x here, right? So you did x and x for your bases. Yeah, sounds good to me. And then this cancels out. 71 carries down. And then we get x to the y power. Yeah. So let's look at the change formula that they give us. So we are in this log form here. We have y equals log base 3 of 81. So it just flip-flopped around. That's fine. So that means going to the answer, the base is the base of the log. So we have x. And then the exponent is going to be what the log equal to, which equal to y. So there's the exponent. And then on the right side, we have just the log of the number, 81. So in this case, it'll be 71. Yeah, so same answer. X to the y power equals 71. Do any of you actually like using this change formula? I despise it. But if you like it, you're more than welcome to use it. Just because I don't like it doesn't mean you can't. I like knowing how to do the math, not a formula that tells me how to convert it. Yeah, if you think it's faster using this, awesome. I don't think it's faster. I think I can do this a lot faster than looking at this change formula, unless you have it memorized. Maybe memorize and you can do that. So I actually do have it memorized, and going from log form to exponential, it's actually kind of simple. Let me just show you how it works. Whenever you have log base 4 of m equals 3 in this case, we're just going to do whatever this is. It's going to be 4 to the third power equals m, and that's how it is. So 4 to the third power equals m. And for me, for going from log to exponential, I would actually just go right to the answer. So 4 to the third power equals m. Now, I'm really good about going that direction. I'm not good about going the other direction. So, yeah. All right, let's everyone try this one. Give me a green check when you finish. Well, you do it both ways. Do it the change formula method, and then do it the algebraic method and see which way works out. Oh, if you're asking like, do I put 132 on the left side and the x to the y on the right side, or vice versa? It doesn't matter. It's an equation. If you have them like flip flopped, like on this previous, see if everyone's done. No, people are still working. So like on the previous page, all of you should have this written down at least. So let me go back to this previous page here. Oops, this previous page. If you notice that I have them, the answer is the same. It's just they're flip flopped. I have the 71 on the right, and then I have 71 on the left. It doesn't matter. Doesn't matter. So radicals, like the plus. So you're talking about standard form. So it sort of depends. Let me go back and make sure I read your question correctly. Well, they're on different sides of the equal sign. So it doesn't matter. Yeah, I don't think one way is more right than the other. Like when you do your quizzes or your test or your final, and it might force you into a certain format. Like if it's like fill in the blank, like sometimes they give you like boxes to put in the numbers for these different like locations, and then they're forcing you to put it in the order they want it. But if you do like a TGA, it doesn't matter. Now, if you're solving for like X, and like let's say the answer is like, I don't know, 100. I don't really want to see 100 equals X. I'd rather you write X equals 100. It's just that's, I don't know. I don't know if that's a better way of writing it. They're both not wrong, saying 100 equals X versus X equals 100, but typically you would want to write X equals 100 when you're solving for a variable. Yeah, if I'm giving answers, I would put the variable first on the left side, equal sign, and then the answer on the right. All right, everyone is done. Eric, are you here? You're tabbed out. Still working? Oh, do you not have a polling thing on your screen to put the green check? Oh, okay. Well, Neuro does that sometimes. It's a feature. It leaves people out. All right, what's the answer for this one? He's not. He's using his computer. I can see it. Yeah, so x to the y power equals 132. What did all of you do to for both sides to solve this? Yeah, you base x both sides. That is correct. And then this cancels out. 132 carries down. And then you have your answer. So x to the y power equals 132. All right, let's go on to some harder stuff. Like this one. Everyone solve for x. I'm going to get my water. I left it in the other room. I'll be right back. Eric, do you get a pop-up now for the polling? Yeah, okay. All right, what did everyone get for their answer? What does x equal? 29. 29, 29. Bunch of 29s. All right, good. Now, did anybody use this change formula to go from log to exponential form for this problem? Anybody do that? Isaiah, you did, and it worked out for you? Good. Well, good. All right, everyone else who did it algebraically, what did all of you do to both sides? Base 5, so let's go ahead and do that. Base 5, both sides. All right, so that means this cancels out. The x minus 4 carries down. What does 5 squared equal? 25. And then your last step was to do what? Add 4 both sides. And 25 plus 4, I think is 29. And that is correct. Good stuff. All right, everyone try this one. And give me a green check when you finish this. What did everyone get? 10, x equals 10. Brady, what happened? Did you do 3 times 3 is 9 instead of 3 cubed? You did 3 times 3 instead of 3 cubed. That'll do it. No, there's a polling that I bring up, and I ask when you guys finish to give me a green check when everyone's done. Then I ask for the answer. That way we all do it together. So some of you are very antsy today. Ah. All right, so what did everyone do to both sides of this equation here? Base of 3. You got the perfect amount of sleep. What is the perfect amount of sleep, by the way? Eric says 2 hours. I don't know if that's true. Maybe for a nap. You guys like 11 hours for a teen? What about for me? What about me, guys? How much sleep should I get? Three cubed is what, Brady? 27. Good job. I try to get like 9 hours of sleep at night. I like 9, but I can do 6, no problem. Well, I don't know about a problem. I don't feel good in the morning. I feel tired, but I can do 6 if I have to. 9? What do you mean how? You just sleep 9 hours. That's how. You just close your eyes and don't wake up for 9 hours. All right, what's our next step here? Kind of an easy problem. You don't have time. I know. Sleep is wasted time. I kind of feel that way sometimes. Yeah, and then we divide by 2. Yeah, I like sleep. It's not when you have, yeah, it's not when you have nothing better to do. Well, you can go like climb a mountain or something. I don't know, go explore. Do something outdoors. Go get some UV rays from the sun and help your body make vitamin D. That's true. That's true. All right, everyone try this one. Solve for X. Ready, go. And then give me a green check when you're done. Don't just give the answer until we're all done. Yeah, I usually work on weekends, and I decided not to work this last weekend, just so I could sleep in on Saturday and Sunday, and it was amazing. All right, everyone's done. What's the answer? What does X equal? Oh, there's definitely a solution. X equals 2. Let's say X equals 2. Or Eric says no solution or 2. One of them is correct, maybe. Anybody else? All right. Did anybody use this change formula to solve this? Yeah, Brady, you need to simplify your answer. You think this thing helps? I think it makes things just harder to look at. But if you love it, love it. All right, what did everyone do to both sides? So solving algebraically, which is how I prefer. What did all of you do? You did a base of x minus 1 both sides. Yeah, that sounds good to me because, well, that's what this is. This is log base of x minus 1 of 1 equals 5. So let's get rid of that log. And remember, we're trying to solve for x here. So we have to free that x stuff from the log base. So we are going to base x minus 1 to both sides. So all of you did that. And then the 1 carries down. Look, we're making progress. 1 carries down. And then we have x minus 1 to the 5th power. Did anybody distribute that 5 exponent to the x and to the negative 1? Anybody do that? Because you're not allowed. That is an illegal math operation. So if you are someone who thought about saying, hey, I'm just going to do the 5th power to the x, 5th power to the negative 1, that is absolutely wrong. You cannot do that. So good. Yeah, the answer is no. Nobody did that. All right. Then what do you do? The 5th root. So we do the 5th root of both sides. So we do the 5th. Oops, that's not my pen. The 5th root to the left side and the 5th root to the right side. And again, I've said it before in this class that we only put plus or minus if your index is even. This is an odd index, therefore it's just what it is. And doing the 5th root of a 5th power, what happens to these? Yeah, they're gone. And then the stuff that's inside carries down. So we get, and then what's the 5th root of 1, Brady? Yeah, it's definitely 1. The 5th root of 1 is definitely 1. So we get 1 equals x minus 1. And then what do? We add 1 to both sides. We got x equals 2. And that's correct. All right. Did anybody, I guess, freeze on this step and you just totally forgot about radicals and how they undo powers? Somebody freeze and you're trying to think too hard on how to do the next step? Nobody? So that means, so who got this one correct? Give me a happy face if you got it right. All right. Well, most of you got it right. Let me, so I'm going to show this problem done a little bit differently. But before I show that, it's actually be really cool. You might be really excited about what we're going to learn here in the next few days. But let me show you this next page before we do that. All right, important logarithms. And we did talk about common log before. I don't know if I called it common log. But whenever you don't have a base, so log, it's invisible, so log of x, it is always a 10. So these mean the same thing. So you, like in your module or in books or quizzes, whatever, my examples, you might see a missing base. And that's because it's always an invisible 10 if it's missing. All right, next, this is also really important, natural logs. So whenever you have a log with a base of e, so log base e of x, we can rewrite log base e as natural log, ln. You have a key on your calculator that has ln. And you'll see me use this a lot. I usually use ln instead of log, just usually, well, really because it's less writing by one letter, log versus ln. I don't know, preference. So let me go back to this problem right here. All right, now I'm going to continue off. Let me be clear. There was like, I don't know, a better way to do this. There's not. Okay. Okay, at this step, I'm going to show you how to do this problem without using radicals. You ready? It's going to be really cool. I'm going to use natural logs. So from this step, I am going to natural log, or I could just log both sides. It doesn't really matter. I'm going to use natural log though, because I like natural log. Natural log both sides. All right, what do you think I can do next? So think of the log properties that we know so far. Ideas. I can bring the 5 in front. Yeah, it's one of our log properties. Also applies to natural log. Yeah, we can bring this exponent in front of the natural log. So, oh, and by the way, natural log of 1 is equal to 0. So natural log of 1 is equal to 0. It's also another, it's not a property per se, but it's something that we should know as we go through this unit. It's not even a rule. So let me break it down over here. So using this little change formula here, so to convert from log form to exponential, you can always look at it as 3 to the y power equals 81. So again, 3 to the y power equals 81, which is what is going on over here. So whenever I look at a different example here. Okay, check this out. 4 to the third power equals m, which is what we got. So 4 to the third power, what's 4 cubed? 64. So m is equal, we actually didn't finish this problem, only because the problem only wanted us to convert, not actually solve. Yeah, so m equals 64. So when looking at these, you should maybe get in the habit of looking at it as 4 to the third power equals m. So when I have, let's go back to that problem here. So when I have natural log of 1, that is the same thing as writing log base e of 1, right? Because log base e and natural log being the same thing. So to solve this, right, we ask ourselves, e to what power equals 1? So e to what power? Remember, e is a constant, like 2.7 or something or other forever. So any number to what power is 1? 0. So natural log of 1 is 0. So I'm basically just breaking it down. So the log base e of 1 is equal to 0. Just breaking it down. So natural log of 1 is equal to, well, 0. But after we do a lot more problems later this week, this should be, this should come pretty naturally. No pun intended, natural log. Natural log of 1 is going to be 0. So, memorize that. But you don't have to. When in doubt, you just type it in. Type in natural log 1, hit enter on a calculator. It'll give you 0. All right. We're going to move this 5 in front of the natural log. Sorry, I'm making this problem last longer than it really needs to be. Because I'm explaining stuff that we're going to learn later this week. But I want to give you a little sneak peek. 5 natural log of x minus 1. All right. What do you think we could do next? What would you do? Divide everything by 5. Yeah, divide the left side and the right side by 5. So 0 divided by 5 is still 0. And now we just have natural log of x minus 1. All right, next. Remember, we're trying to solve for x. It's like we haven't really done a whole lot, but make it look different. So we're going to do, anybody have an idea? So remember, natural log is log base e. Log base e. So what can I do to both sides to get rid of that natural log? I can base e both sides. There you go. So I'm going to base e both sides. And what happens is This cancels out. The x minus 1 carries down. And then what is e to the 0 power? Yeah, e to the 0 is definitely 1. Anything to the 0 power is 1 other than 0, of course. So 1. And then lastly, we're just going to add 1 to both sides, and that's how we get the same answer. That's so crazy. The same answer, and we totally avoided using radicals. How cool is that? I think it's pretty cool. It is a lot longer. You're right. Yeah, the better route would have been just to do the fifth root to both sides. That definitely would be easier. However, what if that 1 wasn't a 1? What if it was like a 2? And then you'll be doing the fifth root of 2, which is, well, then you have decimals. Well, no, you can still do it that way. I'm trying to make this seem better than the other way, but really, doing the fifth root both sides would have been probably the easier way, no matter what it equaled. Yeah, you would have 1. Yeah, you would have 1 plus the fifth root of 2. So, and then that would be your answer. We'll see. Yeah, we'll see how this goes. We're gonna solve more complicated equations later this week. I think starting tomorrow. But the way that I'm presenting this yesterday and today's stuff, it should make the transition solving harder equations a lot easier going forward. And this is, I don't like using this just because it takes away from the actual like math part of it. But you're more than welcome to use this if it helps. I just think it's oversimplified and works when problems are easy, like this, easy like this. But this last page, common log and natural log. All right, guys, any questions before we stop? No? All right, guys. Well, as always, thanks for coming, and I hope you learned something. I will see all of you tomorrow for day 2 of 4.06. So all of you should be done. All of you should have the quiz done for 4.04. I thought there was 3 days of 4.04, but there's only 2 days. So all of you should have that quiz finished as of yesterday. Today is 4.06, day 1. Yep, check the course plan. It has it all laid out on the calendar, showing day by day what we're going to do. If you didn't know that was there all year long. All right, guys. See you next time.